guys, welcome back to my channel. Don't forget to subscribe to my channel for more interesting videos. And for this video, we'll discuss about topic 3.4 where we will talk about the reactions of alkenes, your carbon-carbon double bond. This is the part 1 of it, where in this part, we'll talk about Markovnikov rules. We'll see what Markovnikov said, and also we'll focus on electrophilic addition. So the first and foremost, what did Markovnikov say? Markovnikov stated that in an electrophilic addition, the electrophile is added to the carbon in the carbon-carbon double bond that has more hydrogen. It's quite simple and straightforward. Electrophilic addition means that it will happen to your carbon-carbon double bond. The electrophile, which is the more positive ion, will be added to the carbon that has more hydrogen atom. So let's see an example. This is my carbon-carbon double bond. So the left carbon on the carbon-carbon double bond has only one hydrogen, while the carbon on the right will have two hydrogen. And in the addition of water, you will be adding in your H plus and also your OH minus. So who is your electrophile? Your H plus is your electrophile over here. So what happened is this electrophile will be added to the carbon that has more hydrogen, because that is stated in your Markovnikov rules. The electrophile must be added to the carbon in the carbon-carbon double bond that has more hydrogen. So let's see what happened to the product. The carbon that holding the CH3 remain. Nothing else changed, guys. But what will change is the double bond will become single bond. And then you will have new friend added in. You will have new friend added to both carbon-carbon double bond. But who will be going in? The electrophile H plus will be going into the carbon that have more hydrogen. Therefore, the OH minus will automatically go into another carbon. And that is what Markovnikov trying to say. Simple, easy. So always remember the electrophile will be going into carbon that has more hydrogen in the carbon-carbon double bond. Simple. Let's move into your reactions of alkene. Your carbon-carbon double bond is a very electron-rich site that we call nucleophilic site. It's extremely high in electron in this carbon-carbon double bond area. So when it's very rich in electron, what will happen is it will be attacked by the electrophile. Since you are very electron-rich, so who will go in and to be your friend? The positive will go in and to be your friend. So the electrophile, positive ion, will be going in and attack the carbon-carbon double bond because it's extremely rich with electron. Therefore, the carbon-carbon double bond will undergo electrophilic addition. In this video, we have 6 electrophilic addition that we are going to learn in your alkenes. The first one is your hydrogenation, acid catalyst hydration, halogenation in inert solvent, hydrohalogenation, halogenation in aqueous solution, hydrohalogenation with peroxide. So this is the 6 that we are going to learn in this video. Let's start with the first one. The first one that you have is your hydrogenation. In your hydrogenation, what will happen is we are adding in H2 gas in the presence of your catalyst. Any one of these catalysts, whether platinum, cadmium, or nickel. So this is the way that we write the chemical equation, where you have the presence of your H2 gas and also your catalyst platinum. And what will happen to this carbon-carbon double bond? The double bond will become single bond, and also we will add hydrogen to both of the carbon atoms in the double bond. So whatever that remain unchanged. Because what is changing over here is double bond becomes single bond, and the rest of the atom remain unchanged. And then you form 2 new bonds, each at the carbon-carbon double bond. And what you added in? You add in hydrogen. Simple. Alright, and that is your hydrogenation. where you'll be using your hydrogen gas and the presence of your platinum catalyst. Easy. Let's look at another example. Again, we'll focus on the carbon-carbon double bond, the presence of your carbon-carbon double bond. And what happened is you'll be adding in your hydrogen gas with the presence of your catalyst nickel. Alright, you can use any of the catalyst. And what happened, guys? The double bond will be the only thing that changed. The double bond will change to single bond. And the rest of the group, you basically just copy and paste. And we know that the carbon that holding the double bond just now will be having a new bond on both. And hydrogen is added in because it's a process of hydrogenation where we are adding in hydrogen gas. Easy, simple. Let's move on. Let's look at the second electrophilic addition where you have your acid catalyst hydration. Hydration, H2O, acid catalyst H+. So let's see. We'll be using H2O, H+, as I said, which we also call as acidified water. And after this reaction, you will be producing secondary or tertiary alcohol. And the electrophile in this case is your H+. So in the other words, when you're having your H2O, H+, what will be added in is actually your H+ and also your OH-. So the electrophile is definitely your H+. And according to Markovnikov rules, the H+ will be added to the carbon that have more hydrogen. And then we will add the OH- to another carbon in the carbon-carbon double bond. And that's what Markovnikov said. So focus only on your carbon-carbon double bond, that is your carbon-carbon double bond. Check the number of hydrogen that each of the carbon-carbon double bond having. The carbon on the left having 1 hydrogen. The carbon on the right having no hydrogen. So the one that having more hydrogen is on the left. And again, guys, again and again, those that have no changes will remain unchanged throughout the reaction. And the only thing changed is your double bond break to become single bond. And you will have new bond added to the carbon that just break the double bond. And new friend over here is your H+ and your OH-. And the H+ will be added to the carbon that have more hydrogen. Vice versa, the OH- will be added to another carbon in the double bond. And that's it. And in this case, you're producing tertiary alcohol. Easy, simple. Let's try another example. Make sure you remember to write the reagent and also the condition. The reagent and condition are equally important because you need to show what is added in what condition. So make sure you know the reagent and condition as well. Again, guys, we focus on the carbon-carbon double bond. And before we proceed, we need to check which carbon in the carbon-carbon double bond having more hydrogen. So in a cyclic structure, we know that we hide the hydrogen. So you need to show the hydrogen on the carbon-carbon double bond. So the carbon at the top that holding alkyl group having enough bond already. 1, 2, 3, 4. But the bottom carbon that having only 3 bond, we know that 1 more is actually hydrogen. So the carbon at the top having no hydrogen, the carbon at the bottom having 1 hydrogen. So obviously, who is the one that having more hydrogen? The bottom one. Okay? Let's look at the changes again. The changes will be only changing the double bond to become single bond. The rest of your alkyl group will remain there. And each of the carbon that holding double bond just now will have a new bond. So what will be added in? The H+ electrophile will be added to the carbon that have more hydrogen. And then the OH- will be added to the vice versa carbon. So bear that in mind, in the H2O, you will have your H+ and OH-. And that's it for your acid catalyst hydration. Simple, isn't it? Make sure you identify who is your electrophile, because that is the first thing that we add into the carbon-carbon double bond. Let's look at the next electrophilic addition. You have your halogenation in an inert solvent. And the inert solvent that we always use is CH2Cl2 in this case. Halogenation means, your halogen group 17. So let's see what happened. You will have addition of Cl2 in CH2Cl2 or add in Br2 in CH2Cl2. So you can use both of this reagent and condition. So let's see what happened. The same thing, guys, we will still focus on the carbon-carbon double bond. But for this case, we do not need to check the hydrogen because you are adding in Br2. When you are adding in Br2, means that you'll be adding in Br only. So no need to check the hydrogen. What are you doing is simply breaking the carbon-carbon double bond to single bond, recopy the structure in the question, and the new friend added to both of the carbon-carbon double bond is your Br. And we are adding in Br, guys, because we are using Br2 in CH2Cl2. What happens if you add in Cl2? It will be the same, but you add in Cl. See that? Let's look at more examples. If I'm adding Cl2, also in the inert solvent, CH2Cl2. So what would be the changes? Again, guys, we focus on the double bond. The double bond becomes single bond, and then you have your CH3 remain unchanged. The carbon that holding the double bond just now will have new friend. Both of them will have new friend, and the new friend right now is Cl. Easy. Guys, we only focus on the double bond. Look at what are you adding in, at what condition, and just put into the carbon-carbon double bond just now. So we are not looking at any other carbon, we only focus on your carbon-carbon double bond. Let's try another example. Simple example as well. And I add in my Br2 in CH2Cl2. Alright, that is your inert solvent. So what is the changes? The same. Your double bond becomes single bond. You just copy the entire structure but remove the double bond. And your new friend right now will be your Br because we are adding in Br2. And that's it. Next, we look at hydrohalogenation. Hydrohalogenation means you are still having your group 17 halogen. And then you have your hydro. Hydro means what? H. So, what is happening? You are going to add in hydrogen iodide or hydrogen chloride or hydrogen bromide. That is what you are going to add in. It's a or. So either one of that will be adding in. And you will produce haloalkane or alkyl halide as your product. And in this case, the electrophile that you add in is the H+. So whenever you involve electrophile, you need to check the number of hydrogen. Because the things that you add in right now is a H+ and a Br-. It's a different thing. So when you add in different thing, then you need to check the hydrogen. So let's look at example. Same thing, we are still focused on your carbon-carbon double bond. Check the number of hydrogen that you have on the left carbon. So you have 2 hydrogen over here. On the right carbon, you only have 1 hydrogen. So who has more hydrogen? Because you can only add in the electrophile H+ to the carbon that have more hydrogen. So this has more hydrogen. And your product will be H. Changing the double bond to single bond. Copy the whole structure, remain the same. New friend added to the carbon that holding the double bond just now. And your new friend is your electrophile H+ and also your Br-. So your electrophile will be going into the carbon that have more hydrogen first. And then you have your Br-. Simple, easy. We are adding in H and Br because we are using HBr. What happened when we are adding in HCl? We will still focus on your carbon-carbon double bond. I don't look at other carbon, guys. I only focus on my carbon-carbon double bond. And then check the number of hydrogen each of the carbon having. The carbon on the left having 1 hydrogen. The carbon on the right having no hydrogen. So, who will be the one having more hydrogen? This carbon will be having more hydrogen. So, when you're adding in your HCl, you have your H plus and your Cl minus. So, your H plus is your electrophile. So, your electrophile must be added to the carbon that contain more hydrogen. So, let's look at the product. Before anything, you copy back the whole thing first. You copy the entire structure. Double bond becomes single bond. The rest of the thing remain the same. And then you have new friend added to the carbon that holding double bond just now. The carbon that have more hydrogen, alright, will be holding the H plus. The carbon that have less hydrogen will be holding the Cl minus. Simple. Alright, and that is what Markovnikov trying to tell you. The H plus will be added to the carbon that have more hydrogen, and the I minus or Cl minus or Br minus in this hydrohalogenation will be added to the other carbon. Easy. Last example, we still focus on your carbon-carbon double bond. We are adding in Hi, guys. So, when you're adding in Hi, you know that you're adding in H plus and I minus. Both of them are different things. You have the presence of your electrophile. So, we need to check who having more hydrogen. So, the carbon at the top that holding alkyl group having 1, 2, 3, 4 bond already. But the carbon at this corner having only 3 bond. 1, 2, 3. So, one more is actually your hydrogen. And look at it, you know that this carbon have more hydrogen. So, let's look at your product. And your product will look something like this. New one added to the carbon that holding double bond just now. And the carbon that have more hydrogen will be having H plus. And the other carbon will be having your I minus, your I. Okay? Simple, easy. And that is your hydrohalogenation according to Markovnikov rules. Next, we can have halogenation, still your group 17, but with the presence of aqueous solution, means that you have the presence of H2O. Let's see. We'll be adding in Br2 in water or Cl2 in water. You will be producing halohydrin as the major. In the other words, you will have major minor. And the electrophile in this case is the halogen. In the other words, your Br and your Cl will be Br plus and Cl plus. It will be an electrophile. So let's look at the example. The way that we write is your Br2, H2O on top of the arrow. That is your reagent and condition. So what happened is, again, we will focus on your carbon-carbon double bond. In this case, we will have major and minor. Look at the major first. The major will be adding in Br and also OH to produce the major. So, Br will be the electrophile, therefore Br will become positive, OH will become minus. Where the OH come from? The OH come from the water. So, your Br as an electrophile again need to be added into the carbon that contain more hydrogen. So, the carbon on the left have 1 hydrogen. The carbon on the right having 2 hydrogen. So, obviously, this carbon is the one that having more hydrogen. So, your major product shall look something like this. Double bond becomes single bond. The new friend added to the carbon that holding double bond. And your electrophile right now is your Br positive. So you will be adding Br electrophile into the carbon that have more hydrogen. And the OH minus will be added to the vice versa. And this will be your major product halohydrin. And what would be your minor? Minor is a lot simpler. minor is only adding in your Br. You're having a Br2 just now, can you see that? So to produce the major, we add in the Br plus and OH minus. So to produce the minor, we add in Br. Simple. Alright, automatically this will become your minor. Easy. And that is what happening when you add in your halogenation in an aqueous solution with the presence of H2O. Okay, so let's look at another example. In your halogenation in aqueous right now, I want you to look at the way that I write my reagent. We are no longer using H2O on top of the arrow, but I simply replace the H2O by using bracket aqueous. Bracket aqueous also represent the presence of aqueous, in the other words, water. So looking at this bracket of aqueous, you should already know that we also have the presence of OH minus from the water. And since it's a Cl2 aqueous, we will then have your major and also your minor product. Your minor product is simple. You will be adding in Cl. Your major, you will be adding in Cl positive and also OH minus. Your major, you have your Cl positive and that is your electrophile. And since you know that that is your electrophile, we need to check who or which carbon will be having more hydrogen for you to take in the Cl positive. So the carbon at the top is already having enough 4 bonds. There will be no hydrogen left. But the carbon at the bottom is only holding 3 bonds. Therefore, this guy having another hydrogen. Let's draw your major product first. Your major product shall look something like this. I want to remind you again, nothing changed except the double bond becomes single bond. And the carbon that holding double bond just now will have a new friend, both of them. And the Cl positive will be added to the carbon that have more hydrogen because your electrophile, Br plus or Cl plus, must be added to the carbon that have more hydrogen. So your Cl positive will be coming into this carbon. Vice versa, the OH minus will be added to another carbon. And that will produce your halohydrine major product. Since we have the major, we definitely have the minor, and your minor product shall look something like this. Your minor product is a lot easier because you only add in Cl to the carbon that holding double bond just now. Make sure you label which one is your major and which one is your minor. And in the 6 electrophilic addition that you are going to learn, that you have learned 5 of it, this is the 5th, is the only one that you need to label major and minor. And when the question asks halogenation in aqueous solution, you must write both major and minor. You cannot skip any one of them. You must answer both, you must write both and also label which one is major and which one is minor. Easy. Last but not least, you have your hydrohalogenation in peroxide. The peroxide that we will be using is your H2O2. The hydrohalogenation will be only HBr. And the most important thing is this hydrohalogenation in peroxide will be anti-Markovnikov. So what is meant by anti-Markovnikov rules? We'll look at it later. We'll be using HBr with the presence of H2O2, that is your peroxide, H2O2. And in this case, your electrophile will be H+. Because you have your HBr, you'll be adding in your H+ and Br-. Therefore, your electrophile automatically is your H+. And what did anti-Markovnikov rule say? Anti-Markovnikov rule stated that the electrophile H+, alright, will be added to the carbon that have less hydrogen. All this while, when we follow Markovnikov rules, your electrophile will be forever added to the carbon that have more hydrogen. So when it's anti-Markovnikov rules, your electrophile H plus will be added to carbon that has less hydrogen. And that is what anti-Markovnikov rules is trying to tell you. With only one condition, the presence of your H2O2 peroxide. Okay? So let's see what happened to the product. Again, guys, we'll focus on your carbon-carbon double bond. Since we'll be adding in your H plus electrophile and your Br minus, so you need to check the number of hydrogen on both carbon-carbon double bond. Carbon double bond on the left will be having 1 hydrogen. Carbon double bond on the right having 2 hydrogen. So, who having more hydrogen? This guy having more hydrogen. But we are talking about anti-Markovnikov due to the presence of peroxide. So, let's look at the product. Everything remains the same. Double bond changes to single bond. You have new friend added to the carbon that holding double bond just now. And the friends that will be going in is your electrophile added to the carbon that have less hydrogen. So your electrophile H plus will be added to the carbon that have less hydrogen. And your Br minus will be the one that going into the carbon that have more hydrogen. And that is your anti-Markovnikov rules, where the electrophile will be added to the carbon that have less hydrogen. Simple, easy. The only one that will become anti-Markovnikov is your HBr in H2O2. Okay? Let's try another example. Simple, we'll still focus on your carbon-carbon double bond over here. And we know that this carbon is still holding 1 hydrogen. So this carbon is the one that having more hydrogen. Okay? Knowing that we are adding in your HBr, so you are adding in your H plus and Br minus. But guys, you have the presence of peroxide. So when you have the presence of peroxide, it will then become anti-Markovnikov rules. And what happens when it's an anti-Markovnikov rules? Your double bond shall become single bond, and the rest of your structure shall remain the same. You just copy it back. And then carbon-carbon double bond will have new friend. And the new friend over here, which one will go into which carbon? Electrophile, your H plus, must be added to the carbon that have less hydrogen. So your H plus added to the carbon that have less hydrogen, automatically your Br minus going into the carbon that have more hydrogen. And that is what we call anti-Markovnikov. I want to remind you again, your anti-Markovnikov will only happen when you have the presence of your peroxide, H2O2. And your electrophile H plus will be added to the carbon that have less hydrogen. Simple. And that's it for this video about electrophilic addition and Markovnikov rules. I hope this video helps you to understand a lot better about electrophilic addition. Don't forget to like the video and subscribe to my channel. Thank you for watching, and I'll see you in the next video.